In this lecture, we will discuss about Pythagoras theorem. Pythagoras theorem is in a right angle triangle, the square of the hypotenuse is equal to the sum of squares of other two sides. This is well known. But this time, Pythagoras theorem we will prove with the help of similar triangles. So before coming to Pythagoras theorem, there is one very important theorem based on similar triangles. So first we will take a right angle triangle. This triangle is right angled at B. So the theorem says, if we drop a perpendicular from the right angle to the opposite side, and in front of right angle, whichever is drawn, the opposite side will be always the hypotenuse. So if we drop a perpendicular from the right angle to the opposite side. Now, when we have dropped this perpendicular, then this line has divided this triangle into two other triangles. So theorem says the perpendicular drop from right angle to the opposite side gives two triangles which are similar to each other, as well as individually this smaller triangle will be similar to the original one, and this second triangle will also be similar to the original one. Now, in the beginning we had this right angle triangle. I am numbering the angles. Okay, this is 1, this is 2, and this is 3. Now, I have dropped this perpendicular which has given two triangles. One is ABD, which is a right angle triangle. Another one is BDC. Now, how to write the correct order of similarity? Here I said this is 1, that will not change. This is 3, that will also not change. Now, here this angle B I have numbered as 2. It means right angle is 2. So wherever right angle is falling in these two triangles, we can number them 2. So this is 2, this is 2. In this triangle, what is left out? 1, 2, so this will be 3. In this triangle, 2 and 3 are there, so this is 1. Now we'll go back to the original one. This is 3 angle. It means this angle 3 will be equal to this C. Okay? Similarly, this angle 1. This is 1, and here what we are getting? This angle is 1. So this will give us the correct order. Now let's see how. This is the original triangle that we will number it as 1, 2, 3, A, B, C. 1, 2, 3. Now second one. I want to write the correct order. I'll just go by the angles. Angle 1 is A, angle 2 is D, and angle 3 is B. So this is one triangle. Third one is, here 1 is B, 2 is D, and 3 is C. So what have we got? 1, 2, 3, 1, 2, 3. This is the correct order, means this triangle is similar to this triangle, is similar to this triangle. So what is the result? If we drop a perpendicular from the right angle to the opposite side, the made two triangles are similar to the original one, means this one, and they are similar to each other. Now what is the property by which they are similar? They are similar by AA, corollary, because you can see in this triangle and this triangle, angle A and angle A both are 1. 190 degree is there. That is 190 degree is there. So two angles are sufficient. Okay. Similarly, this one and this one, when we compare, angle 3 and angle 3 both are C. Angle 2 and angle 2 both are 90 degrees. This third one I wrote later on. But earlier we had already two angles equal. So two angles of this triangle equal to 2 angles of this triangle also equal to 2 angles of this triangle. So it means that these all three triangles are similar to each other. This is one theorem. This theorem we are going to use to prove the Pythagoras theorem. So very important concept is what? The order of these three triangles which are similar. So now we will prove Pythagoras theorem. So what we have seen in this result, in this theorem, that when we had dropped the perpendicular, then these two triangles are similar to the original one. Okay, original one means triangle ABC, and so they are similar to each other. So in general, we have written all these three triangles are similar. Now we have to prove the Pythagoras theorem. For that, we will only see this right angle triangle ABC. In this right angle triangle ABC, we have to prove AC square is equal to AB square plus BC square. This is the statement already of Pythagoras theorem. We know in a right angle triangle, the square of hypotenuse is equal to the sum of squares of other two sides. Now, one pair at a time we will take, then we will get the result. So first I am taking ABC and triangle ADB. Now when we prove this Pythagoras theorem, we will already discuss that this is one of the results what we are going to use in Pythagoras theorem. So for that, our construction will be what? Drop a perpendicular from B to AC, that is BD. That will go, this is to be proved. Okay, and what is given to us? That a right angle triangle ABC, right angled at B. This is given to us. Now we have done one construction, and when we will do the construction, that construction BD is perpendicular to AC. So that will go in this column, construction, draw BD perpendicular to AC. Now the minute we say draw BD perpendicular to AC, it means we can use that previous theorem. And according to that theorem, these two triangles are similar to ABC and they are similar to each other. So now one set at a time we will take this. We have to write separately according to the theorem. Now one set I will take, that is, first I am taking triangle ABC is similar to triangle ADB. Now why is it similar? We will write in short the reason over there. A perpendicular drop from the right angle to the opposite side will give two triangles which will be similar separately to the original triangle as well as they are similar to each other. It means all three triangles are similar. Now when we know the triangles are similar, their corresponding sides will be in the same ratio. So our need is AB square and BC square. We are not going to find out how are we going to get AB or how are we going to get BC. We will simply take one set at a time and we will write all three corresponding sides in the same ratio, and out of that we will choose what we require. So here AB upon AD is equal to BC upon DB is equal to AC upon AB. What is our need? AB square. And how are we going to get? If we multiply this and this, we are going to get AB square. It means we will neglect this part. This we don't want. So directly what will we take? These two. So that we will write separately. That is AB upon AD is equal to AC upon AB, which will give us AB into AB by cross multiplication. AB square is equal to AD into AC. Similarly, we will take the second set, this triangle and this triangle. Then we will see what are the corresponding sides. Second part I am taking that is triangle ABC is similar to triangle BDC, these two triangles. Again, we will write the corresponding sides in the same ratio. AB upon BD is equal to BC upon DC is equal to AC upon BC. Now, our need was AC square is equal to AB square plus BC square. Already we have got this AB square. Now what is our need? BC square. So those two parts we will take, which will give us BC square. So one BC up and one BC down, on cross multiplying we will be getting BC square. So this we will neglect. And what are we taking? BC upon DC. By these two, directly I am multiplying it. So we are getting BC square is equal to DC into AC. Clear? Now, AB square plus BC square. So AB square and BC square we have got here. We will add it. So by 1 and 2, add AB square plus BC square. Now the value of AB square is AD into AC plus the value of BC square is BC into AC. Now from these two, what is common? AC. What is left out? AD plus DC. Now come back. AD plus DC is equal to AC. So this will be, so what have we got? AB square plus BC square is equal to AC square. Or we can say, therefore, the square of hypotenuse is equal to the sum of squares of the two sides. And this is the Pythagoras theorem. But what have we done? We have taken help of similar triangles. So we have proved the Pythagoras theorem by using the results of similar triangles. Now we'll discuss converse of Pythagoras theorem. So if it is given in a triangle, the square of one side is equal to the sum of squares of other two sides. Means it is given that square of one side is equal to sum of squares of other two sides, then the angle opposite to this side, whose square is equal to the sum of other two sides square, will be a right angle. Means we have to prove the angle opposite to AC. This angle we have to prove right angle. For this we will take one construction. We will take one right angle triangle in such a way. This is already a right angle triangle. This is construction. In such a way that PQ is equal to AB and QR is equal to BC. Now we have to prove angle B is equal to 90 degrees. If we can prove this triangle equal and congruent to this triangle, then angle Q will be equal to angle B and that will be 90 degrees. Now let's see. How can we prove this? So this is given. AC square is equal to AB square plus BC square. We have to prove angle B is 90 degrees. Construction is, take a triangle PQR such that angle Q is 90 degrees, and also we have taken PQ is equal to AB and QR is equal to BC. This is the construction. Now, for the proof, we will take this triangle first. In triangle PQR, this is already given that this is 90 degrees, so we can apply Pythagoras theorem over here. So PR square is equal to PQ square plus QR square by Pythagoras theorem. But what have we taken PQ? Construction. PQ we have taken as AB. So if PQ is equal to AB, PQ square will be equal to AB square. So in place of PQ square, what can we write? AB square. Similarly, QR square will be equal to BC square. Since QR we have taken as BC, so its square will also be equal. So in place of QR, we will write BC square. We will write the reason over here. Since by construction, PQ we have taken is equal to AB. So PQ square is equal to AB square, and we have taken by construction these two sides are equal. So their squares are also equal. Now, AB square plus BC square is given equal to AC square. So what will we do? We will replace these AB square plus BC square by AC square. So what are we going to get? Here you will write the reason. Since AB square plus BC square is equal to AC square. Now if PR square is equal to AC square, it will give us PR is equal to AC. What have we got now? Already the construction PQ is equal to AB, QR is equal to BC. And what have we got the third side? PR is equal to AC, that we have proved. It means that by SSS, these two triangles will be equal and congruent. So we will write by SSS congruence condition, triangle ABC is equal and congruent to triangle PQR. You can say these two are equal by construction, and this already third side we have got. So, therefore, by CPCT, angle Q will be equal to angle B. But what was the construction? Angle Q is 90 degrees. Therefore, since angle Q is already 90 degrees, so what we have proved? Angle B is also 90 degrees. So, what was given in a triangle? If the square of one side is equal to the sum of squares of other two sides, then it is a right angle triangle. In some words you can say like this, or what you can say, the angle opposite to that side, whose square is equal to sum of other two sides, will be a right angle. So we have proved angle B is equal to 90 degrees.